We are here to cover some SAT geometry questions to learn everything we need to know to crush this test. There's not that much stuff. We're going to jump right in with a series of questions that I've compiled from old SATs. The current test hasn't really changed in any way for the geometry section. It's just a stack of basic skills from geometry that maybe in the rearview mirror, maybe something that you're a little rusty on, but we're going to pick them up as we go. If you have foundational issues with geometry, like you really don't know what's going on, you should use Khan Academy, you should use other resources. This set of questions, this course is here to help you with taking that knowledge and applying it to the SAT. If you have no skill whatsoever in geometry and you feel like I'm moving too quickly for you, then by all means try to fill in that knowledge using Khan Academy and then come back here, because I promise the way that I'm looking at these questions is probably the most efficient way that you can tackle questions on the SAT. Okay, so I'm going to start with this question right here. I'll read the entire question and then we'll jump in. It says, x minus 6 quantity squared plus y minus 3 quantity squared equals 25. The graph in the xy plane of the equation above is a circle. If the circle is translated downward a unit such that the circle is tangent to the x-axis, the equation becomes x minus 6 quantity squared plus y minus 3 plus a quantity squared equals 25. What is the value of a? Okay, so when I'm taking this test, what I would recommend that you do is start with the last sentence. Sometimes it's a really helpful sentence. Sometimes it clarifies what you're asked to do. I also would say if you have answer choices, you should use them. In this case, we don't have any answer choices, which does happen quite a bit on the test. We do have an equation. This equation tells us that the center is positive 6, positive 3, and that the radius is 5. This equation is x minus the center, y minus the center. When I say center, I mean the x and y values of the center. Oops, let's not say 3, let's say y minus k squared, and this equals the radius squared. So hk is 6, 3. Radius is 5. Opposite signs in parentheses. Okay, so if I give myself kind of a rough sketch of what's going on here, at like positive 6, positive 3, we have our center, 6, 3. And the radius would bring, we're going to translate it down, but this top point would be, 5 units up, which is 6, 8. Really easy to make mistakes with x and y here. So make sure that you've gone with a translation up and you haven't written, for instance, like 11, 3, where you've added 5 to x as opposed to y. The bottom of this circle would be 5 units down from 6, 3 at 6, negative 2. Okay, so I don't need a beautiful sketch, and you won't have time for that on the test, right? So what's happening? The circle is translated down, and we're going to be tangent to the x-axis. As you go through this material, be making a list of any vocabulary word that you feel like you don't know the way it's being used, right? You might know tangent from trigonometry. Basically what it means is it's touching something once. You could think of the way we use the word tangent in conversation. We say somebody went off on a tangent. It means they started at a point that was relevant, and then they launched off and they never got back to the point on which they were supposed to be talking, right? If you're in a history class and your teacher starts talking about, car values or something, maybe they started by talking about Henry Ford and the history of manufacturing in the United States, and then they start talking about Ford vehicles, and then they start talking about their own vehicles. They're off on a tangent. To the extent that they bring their conversation back to the central point, then perhaps they're not on a tangent, right? So at least technically. So a tangent here means it touches the x-axis once, and we're translating downward. So instead of bringing 6, negative 2 up, we're bringing 6, positive 8 down to 6, 0. Okay, so our center is actually now going to be from 6, 3 down, 5 units below this top point, which is 6, -5. Okay? Moving in small stages is how you ensure that you don't make a mistake. Think about how many times I've checked in with something small as opposed to, sort of piled this up on top of itself without checking in. I could have easily made an XY mistake. I could have easily confused my tangent point for the center. 6-3, instead of going down 5 units, which, would make some kind of sense, 6-8 went down 8 units to 6-0, and so 6+3 went down 8 units as well, to 6-5. Okay, so this is y plus 5 is the final equation. So basically, again, you could kind of shortcut this, but we want -3 plus a to equal that 5. Because opposite signs, -5 is the center, that means y plus 5. Now I'm just solving, add 3 to both sides, a is 8. Of course, you could say that, maybe you had the answer a minute ago. I'm telling you that it won't take you nearly as long when you're not talking through it to be methodical, and you should be methodical on questions like this. So a equals 8 on this question. We'll keep going. All hard questions on this doc, or, harder questions, or easy to get wrong questions, if you will. Okay, so we have a figure. It's a circle with points F, G, and H on the circle. We have a triangle. Triangle FGH is inscribed in the circle above. If arc FG is congruent to arc GH, there's another vocabulary word. Congruent here means equal, right? So this length, sometimes we put a little line there. That's the same as this. The measure of G is 30 degrees. And what is the measure of H? There are helpful assumptions to make. I want you to associate angles and the sides that are across from them. All right, so H, the angle at H, is across from the line FG, or the line segment FG. And angle F is across from the line segment GH. Okay? Feel free to pause here and see what you can do with that information. What I'm going to say is that if this arc length and this arc length are the same, then so too, the basic fact is that angle H is congruent to angle F based on that fact. That's like a property of inscribed angles. It's worth knowing. It's also the case that, therefore, these line segments FG and GH are also the same. And the measure of angle H could then be determined by using the simple fact that a triangle has 180 degrees. And if you subtract 30, you get 150 remaining degrees. And those 150 degrees must be split up evenly between two equal angles. So half of 150 is 75. Right. So hopefully that's helpful. That's kind of a fact worth knowing, the relationship. Basically, everything's proportionate when you're dealing with circles and triangles. Look for similarity, look for proportions. That can be a really helpful fact. Right? Okay, so there's one other fact I want to drop on you here because it will come up again. If I know that this angle is 75, if I were to go to the center, let's say this is the center, this angle at the center, the so-called central angle, would be twice as big, 150. And for what it's worth, maybe we can do this with a couple other angles. If this one would also be 150, right? And we said earlier that this was, I think, 30 degrees, which means that this angle here should be 60 degrees. And you'll notice those add up to 360. Right? So a circle is 360 degrees. Notice that the inscribed angle G is half of the central angle here. And the same for the 75 was half of the 150. Right? So that's a fact worth knowing. Okay? Let's continue onward.